So first one, we're asked to prove two lines are parallel and told two lines are parallel, so we can use some of the parallel line angles that we have and just be careful which ones we're using. And obviously we'll start with this given. But it's not completely marked, and actually, well, just the angle congruence is not marked in the figure, so let's mark that these two angles are congruent. Why is this not working? All right, there we go. So I've marked that 1 and 2 are congruent since we were told that they are. And we've seen a number of proofs now that are like this. So hopefully you're kind of getting the flow of them. There is variety. Sometimes you'll see a different version, but a lot of them are similar. So we need to link 3 to 2 without using the fact that they're corresponding, because we don't know that lines A and B are parallel yet. That's what we're trying to prove. We know that 3 and 2 are parallel, are corresponding. That's the kind of angles they are, but we can't say that that's why they're congruent. So what else can we do? We need to be able to connect 3 and 2. We will do that, yep. But we need 3 in the proof, like in the argument. So far, 3 has not been mentioned. So what do we know about 3 that is helpful? Yeah, how come? Let's see. So we're looking at these parallel lines with that transversal, and it's that situation. So not alternate exterior. But yeah, those are corresponding. Remember, you can always turn the figure, and even on your paper, like turn that whole paper if it helps you see it better. So angles 1 and 3 are corresponding, and because we were told lines L and M are parallel, it's fine to use that. So that's corresponding. And the name of this thing is corresponding angles theorem. That's what tells us they're congruent. And of course we can just say cat if we want. Okay, and then Parker told us let's substitute 2 in for 1. And why are we doing that? That's why we can. So good. 1 and 2 are congruent, so we can just stick a 2 wherever we see a 1. But why did we want to do that? Like, what was the purpose of it? Yeah, so we can use what? Just to remind you that to prove parallel. Yeah, these are the only 5 ways we can do it. And so we have to, something in this pink circled thing has to be proven a different way. And then once it's proven, we can say then the lines are parallel. And so we just did this first one. We proved that corresponding angles are congruent by substitution. So it was that backdoor idea. And so we can use converse of cat just like Parker said. So A parallel to B by converse of cat. Okay, how'd that go? Awesome. Remember, we have an assessment coming up. I think we'll we'll do it on Wednesday because we don't have school Monday. So review, we're going to start review today. We'll review some on Tuesday, and then that final test for this first giant unit we'll do on Wednesday next week. You'll have a couple proofs, but the majority of it is solving, actually. So I'll put this one on here to start reviewing for that, because this kind of thing, any kind of review item could be on there. How do we find distance between 2 points? Oh, is it? Well, we have a distance formula. Anybody remember that? Nice. Yeah, where x2 and, well, let's just write it this way. Remember, we have 2 points, so I would call this probably x2, y2, and this would be x1 and y1. So the x's and y's just come from the coordinates of the points that we're given. And we just plug them in. Just be careful with how you work through the formula. So x2 is 4, and x1 is -3. That's a common thing, is to miss that second negative sign. And then y2 is 5, and y1 is -2. And then we just kind of work through some basics here. What is 4 minus -3? It's 7, yeah. So make sure you check that on your calculator. Oh, also leave the parentheses on there. 5 minus -2, what's that? That's also 7. And then we square. Nothing under here should be negative. 98, which is fine, so just leave it like that. You could also square root it and get just under 10, like 9.85 or so. So square root of 98, how'd you do? Raise your hand if you got that. Correct. So distance formula. Guys, anytime you have a formula, it seems like it should be kind of easy points, because you just write the formula, plug in numbers, and work through some, I mean, this is, it's subtraction. Let me just highlight subtraction here, addition and squaring, and then that's it. We don't even have to square root for the answer to be correct. So get that on your note card if you don't remember it. And let's quickly review. I didn't put this on the warm-up, but also let's do a quick review of midpoint. If I said, where's the midpoint between those two, what would we do? We know it's going to be, like, just visually somewhere in here, right? Now, I didn't draw this to scale, so it's probably not perfectly accurate, but how do we find midpoint? Yeah, Isaac?
x1 minus
And don't forget the over 2 part. So we're averaging, like, hey, how far are these x1, x2? We add those and divide by 2. That puts us right in the middle of them, just like it would if we averaged our height or something. And then I'm just subscripting x sub m. That just means the midpoint coordinate, right? And then these are just different x's that are involved. So it's similar to what we did in the distance, only this time we're adding, so we have to be careful. So -3 plus 4 divided by 2. And over here, -2 plus 5 divided by 2. So -3 plus 4 is just 1. So the x coordinate is 1/2. And then -2 plus 5 is 3. So the y coordinate is 3/2. And since it's a point, we do want to write it as a coordinate pair. So 1/2, 3/2. Sometimes I noticed when I was grading that people forgot to divide by 2. So don't forget that part on your formula. Does that stuff ring a bell? Okay. We've learned a lot so far, so make sure you're staying caught up with it. And let's go check your proofs. So grab that packet, the homework packet. Any of these Really, you should have only had 3, 9, 10, and 11. So any of those you'd like me to do before we just check answers? Any of them harder than others? 5, okay. So just getting the givens on here. And notice that G parallel to H is not shown in the figure. So that should be added. Remember, we just put arrows for parallel lines. And then we're asked to prove that angle 6 and angle 2 are supplementary. That they're congruent. And one temptation here is to assume that these two lines are parallel because they look like they should be. Can we? No, we don't want to make assumptions. So 6 and 3 are supplementary. And here's another thing that's true. Angle 2 and angle 3 are supplementary also.
Same side interior.
Yeah, since we're told G and H, those two lines are parallel. These are same side interior angles. And so they're also supplementary. And that's a postulate. So we can abbreviate SSIAP. But please make sure you know, if you're going to abbreviate, make sure you know what the abbreviations mean. All right, so this is kind of a shortcut version of the proof. If 6 is supplementary to 3 and 2 is also supplementary to 3, then what is true about 2 and 6? They've got to be, because they're supplementary to the same angle. So this is kind of a shortcut version of a proof for this, but it's okay right now. And what do we call that? And it's technically a version of the transitive property. Two angles supplementary to the same angle. Now, like I said, there's a little bit more rigorous version of this proof, but since we're so early on in proofs, I'm going to accept that. Did that help? Okay. Any others that you'd like me to do before we just check them? Okay. Let me put those up here then. So number 9 is there. That one is it's very similar. It's not the same, but it's very similar to the warm-up problem. The only difference between this one and the warm-up is that the 3 would be right here. So it was corresponding. But otherwise, the proof is the same. So in this case, converse of what is AEAT? Yeah, alternate exterior angle theorem, since 3 and 2 are alternate exterior instead of corresponding. But make sure you say converse. If you don't say converse, then you're using the wrong theorem and it doesn't actually prove those lines are parallel. All right, number 10. There's 10. The line labels got dropped on this for some reason, but I think it was probably okay to figure out. Something about this tells me that I think I put 3 in the wrong place or different place. Did you guys have a 3 that you put on here or anything like that?
3 is on the top corner where the dot is.
Oh. Okay. So he's saying 3 should be here. I'm not sure why I wrote it there. So basically the only thing that changes is 3 and 2 instead of cat would be alternate interior. So AIAT. And then, yeah, to prove P and R. Substitution is still good. And then we're trying to prove PR. It would be converse of AIAT again. Yeah. Is that what you said? Yeah. Huh. Wonder why I put that 3 right there. Number 11. Anyway, we're trying to prove P and R are congruent, or excuse me, parallel. P and R are parallel. So G and H, we're told are. So 1 and 2 are alternate interior. Angles 1 and 4, do they have, other than being given, do angles 1 and 4 have a direct relationship? No. Okay. And then I converted over into algebra mode using a definition of supplementary angles. And then down here, again, definition of congruent angles allowed me to convert into algebra mode. And then with that, I was able to just substitute. Let me use this thing. Actually, I can't. Hold on. In here, because I have it in algebra mode, now I can just plug those into an equation that says they add up to 180. So that's kind of the more rigorous version of the proof. But if you kind of work through it without the algebraic conversions, I think you're probably okay as long as your logic is there. And then don't forget again to say converse, and in this case, same side interior angles, because 2 and 4 add up to 180. So that proved that those were parallel. Is there another way to do this one? And that's true often. We could have used 3 and 4, and then our last line, we would have had to prove 3 and 4 are congruent, and then our last line would say converse of AIAT, the alternate interior angles. And so that would be a slightly different proof, but also a valid one. I think based on the labeled angles, those are the only 2 options. So, how'd you do on parallel line proofs? Feel like you're doing okay with them? Okay. So we're going to do a quick check-in on that, and then after that we'll start reviewing angle solving. You'll need to pull out your Chromebook, and let me show you what you're going after. So I posted it this morning. It's not the full post for the day, but it's got what you need for now. So this post, just go to your stream, and the posts have both things that we're going to do. Right now, I want you to go to the Google Forms post there, the link, and there's a check-in on proofs. And so you're going to have to ask me if, let me log in and I'll show you. It's kind of a weird thing to put into a Google form, so just do your best. But you can kind of see on this first one, it says put the following pieces of information in the correct order to develop. This is saying a flowchart proof, but same idea as what we do as a 2-column proof. So I do want you to do your own work on this to check how you are individually doing on it. And probably 10 minutes is enough. I don't think it'll take longer than that. If you don't have your Chromebook, I guess I can just put these up here successively and you can just write them down. So there's the first one. On this one, maybe just do kind of like a quick dot pattern for where you would fill stuff out if you're doing it on paper. look at yours? No, we're not. We're doing the Google form. Did you do it yet? We'll do that after. Yeah, I think so. I can't hardly see. But yeah, that. No. When I tried, it didn't show me all the options. Can you scroll down? What the heck? Is it like just giving you the one option to submit? Okay, that's what it did to me too. This is, by the way, not just a me thing. It's like all the geometry classes thing. So I'm not sure what's going on. I will check in with the teacher who made it and see if they can fix it, because it just, like, did it do for you like the circles and then you hit submit, but then it acted like there was a bunch more questions?
Yeah.
Okay, that's what it did to me too. So I don't really, and then you can't go back and fix it. And I'm not sure if I'm an editor on here. So, you know what? Let's just not worry about it. Just go ahead and get off there. And I'll figure out what the problem is and let you know. But this is an angle review. This is also on there. And this is going to take a little while, as you can tell. You guys ever heard of Dinky King? What is it a play off of? Donkey Kong, yeah. But this is Murio, not Mario. Anyway. Here's what I want, though. Not just finding the angle measure, so listen carefully, because down at the bottom, it mentions this, but I do want you to do this part. It says, please explain how you calculated each angle. And what I mean by that is I want you to say things like, oh, that's corresponding to whatever. Okay, so let's zoom in on a piece of this. The horizontal lines are parallel. And then what else, actually, before I say that, what else is in here that you're going to use? Besides parallel lines, I mean. Triangle sums, right? Adding up to 180. What else? Like, let's say for some reason you had to use P, Q, and R. What do they add up to? 180. That's a straight line. That's not a linear pair because it's 3. But like UV is a linear pair. They would add up to 180. Same with WX. What kind of angles are XY? Those are vertical. So all those different kinds of angle relationships you can use in here. How about, let's pick 23 and P. What kind of angles are those? Those are alternate interior. So when you solve for each angle, like when you say P equals, I want you to say P equals 23 and then put alternate interior, or AIA, with 23. And so you're practicing your explanation and identifying those angle pair types as well. So questions on what you're going to do for a little bit? Okay. I don't know how you feel, but I probably would just work bottom to top. That's how I would do this, just to stay organized and not miss anything. But, yeah. Yeah, do this on a piece of paper, and we'll check it. It's probably going to take a little while, maybe 20 minutes or so. And again, this is practice and starting review for your test. So think of it that way and try to treat it as review.